Question number 7. A ball is thrown up vertically. You are throwing a ball vertically upwards, which means you are applying some energy here. You are giving a kinetic energy here with a velocity u. The air resistance negligible. What is the variation with the time t of the kinetic energy of the ball? So what happens? Okay, the ball goes upwards, goes to a certain height, and again comes down and falls to the ground. Okay, so he is asking you what happens to the kinetic energy. So kinetic energy, what will happen to kinetic energy? Kinetic energy will reduce, right? Which initial kinetic energy is half mu square. But if you take the total kinetic energy, what will happen is, let us say at any instant, you can write this as it's equal to half into m into v square at any instant, right? Kinetic energy at an instant t will be half mv square. This is your initial, which can be written as half m into u square minus 2gh. Okay. Oh, I don't want height. Okay, I want with respect to time. So we can write v equal to u plus at, which is nothing but u minus gt. U minus gt. If I substitute it, I get the answer as kinetic energy is equal to half m into u minus gt the whole square. Now you see that this is kinetic energy is proportional to t square over here, which means it should be representing a parabola. So based on this, now you see these two are out of our contact, right? Only these two could qualify for it. Which parabola should I take if I want to answer this question? Now reason it logically. If I put a t equal to 0, what do you mean by t equal to 0? The particle was here. What was the kinetic energy of the particle? Kinetic energy of the particle was very high here, right? At t equal to 0, kinetic energy was very high. You can see this from the equation also, which is half mu square. Which means, if you look at this here, at this point, at t equal to 0, kinetic energy is 0, which is definitely incorrect, right? See, these are something called as understanding the problem using the boundary values. Okay, what is boundary value problems? So D is the right answer. Okay, let us move on to the next one.